Today we are talking about networking. Computer networking is a topic that can take several classes to cover in depth. We don't have that, so today we're going to look at the main concepts. The essence of networking is the ability to communicate. This communication can be between two users or between devices on a network. Basically, a network can be classified by the device that controls the network. If there is no single device controlling the communication between users or devices, then the network is probably of the type called peer-to-peer. If there is a server controlling traffic, then the network is a server-based or client-server network. Another way networks are distinguished is by geography, or how close devices are to each other. Networks where all computers are in closer proximity are called local area networks, or LANs. Most networks we'll be talking about and looking at are LANs. Networks where the devices are physically distant from each other are called wide area networks, or WANs. Another characteristic of a wide area network is that the service for connecting devices or local area networks together is provided by a carrier. To be able to connect to a network, three things are necessary: a network interface controller, a protocol or language for communication, and a network client. We'll go into specifics about these in just a minute. First, these basic concepts. Data to be transmitted across a network must be broken down into small chunks called packets or frames. Every data packet contains certain specific information, including the unique address of the network controller in the PC that's sending the data, the unique address of the network controller in the PC where the data is going, the specific data or information itself, and some sort of data or error check that ensures that the data was received intact. Let's take a closer look at that unique address for the network controller. Every NIC manufactured has its own specific binary address called the MAC, or Media Access Control Address. No two NICs will ever have the same address. These addresses are represented using hexadecimal characters, and your system information utility can display that address. Your text gives an example. No matter what architecture or topology is used to send data, it will always be broken into packets. What do these packets travel across? In most networks, they travel across some kind of wire, although wireless networks are growing in popularity. Every network is laid out and connected in a specific way. This is known as the topology, or network architecture. The most common layout, also known as a hardware protocol, is Ethernet. Ethernet is based on the bus topology, where the components are connected in a line. Each component, when it wants to talk to another over the network, has to listen to make sure no one else is talking. It's like old party line telephones. You couldn't place a call until the line was free. This type of use is known as CSMA/CD, which stands for Carrier Sense Multiple Access Collision Detection. If two components want to talk or send data at the same time, there'll be a collision. The data will be destroyed and the senders will have to try again, hoping their packet would not run into another one this time around. Another consideration on a bus is that it has ends. Because packets want to keep moving, when they reach the end of a wire, they bounce back or reflect. If this bouncing back isn't somehow stopped, the network cable becomes full of bounced back packets and no further communication will occur. To prevent this reflection, the ends of a bus network are fitted with terminators. These devices absorb the signal and keep the network open for communication. The main drawback to a bus layout is that if there is a break anywhere in the cable, the entire network goes down as the signal can't progress. Because a straight bus doesn't support very many systems, Ethernet connects groups of these bus networks together. The bus part of the network is contained in a device called a switch, which the workstations get connected to. Business-sized switches can support 32 or even more devices. Switches then are connected together and are eventually connected up to a server. When the network is set up in this way, it's referred to as a star bus topology or architecture. This provides a more stable network environment. Breaks in a cable are confined to one group of systems connected to a single switch. When you isolate the problem area, communication on the rest of the network continues unimpeded. There have been several kinds of Ethernet over the years. These are generally identified by the type of cable used to connect devices on the network: coaxial cable, unshielded twisted pair, and fiber optic. Because each of these uses the same packet type, you can have any combination of hardware devices and cabling in an Ethernet network, but in general most will use the same kind of cable. Today that cable is most likely to be unshielded twisted pair, most often referred to as UTP. UTP Ethernet today can run at 3 different speeds: 10 megabits per second, 100 megabits per second, or 1000 megabits per second. The technical name for each of these is 10 base T, 100 base T, or 1000 base T, also known as gigabit Ethernet. We are now also seeing some 10 gigabit Ethernet networks. To encompass all of these, the term is 10 star base T, or just Ethernet. To support these speeds, particular grades of UTP cable are used. These are known by their category levels, which define the maximum speed at which they can transfer data, their bandwidth. Today, the common category cables used with Ethernet are Cat5 for speeds up to 100 megabits per second, Cat5e speeds up to 1 gigabit per second, and Cat6 speeds up to 10 gigabits per second or 10,000 megabits per second, and 6A, which is also 10 gigabits per second. To connect to NICs or ports on switches or routers, these cables use RJ45 connectors to array the cable wires. Generally, one of 2 wiring schemes are used when putting connectors on cables. These are shown in your book. All cables on the network should use the same scheme to prevent confusion. As networks got bigger, it was discovered that if a device was too far from a server or from a hub or switch, the data didn't go through well. The distance any device can be from a hub or switch, therefore, is 100 meters. If a group of PCs or other devices is quite far from a server, a signal amplifying repeater is inserted in the chain to keep the signal strong. Once you get into the network, you still have to communicate with the various devices, and of course there are rules to be followed for this communication. These rules or protocols take the incoming data, keep it organized, send it where it needs to go, receive it when it gets there, keeps it organized on that end, and then hands it off to the workstation operating system. The most popular software protocols are NetBEUI and TCP/IP. NetBEUI isn't often used on large networks because it doesn't work with routers. These are devices that determine just what part of a larger network a packet is going to. TCP/IP was originally developed by ARPANET, the forerunner of the Internet, as its communication protocol, and the Internet is probably where most of us have become familiar with it. It's now the most often used protocol for local area networks as well as for the Internet. TCP/IP is not just one protocol. It's a group of utilities that work with different tasks and under different situations. Let's look at a couple. Remember that we mentioned the MAC address on network cards. On simple networks like peer-to-peer networks, workstations must have unique names. On a TCP/IP network, PCs have an IP address. This identifies the PC to the network at large. It's a unique identification number in a form called dotted decimal. For example, 205.205.205.205. Part of this identifies the network the system is on, and part identifies the local computer address on that network. Your book goes into some detail on IP addresses, things like binary address translation to dotted decimal, IP classes, and subnet masking among them. But for our purposes, just know that these numbers mean something for identification purposes. Besides file and print sharing, TCP/IP does other things, known as services. The most famous is the protocol or language of the Internet, HTTP. And this is why, if you want to get on the Internet, you need TCP/IP, because it contains HTTP, the language of the web. TCP/IP needs to be set up if you're going to connect to the Internet. When you connect to the Internet, you're not connecting to all the other devices individually connected to it. You're connecting to a gateway, a device to which others are attached. The one you use to gain access each time is called your default gateway, and this generally resides at your Internet Service Provider, or ISP. We're not very good at remembering a multitude of IP addresses that represent all the Internet or network areas that we want to visit. Domain Name Service, or DNS servers, keep databases of IP addresses along with their corresponding names. When you type in a name, the system queries the DNS server to get the IP address and finds the correct web destination for you. To be registered for a domain name, you must pay a small yearly fee. Then you can use that domain for your business, educational institution, government site, and so on. Your workstation may not always have the same network identification or IP address. You might receive a new one each time you log in from a machine known as the Dynamic Host Configuration Protocol Server, or the DHCP server. Because there is a finite, although large, number of IP addresses, if a system isn't on the network, it doesn't need an IP address. So the DHCP server keeps track of which addresses are being used, assigns one to your system when you log on, and frees it up for someone else when you log off. IP addresses assigned this way are called dynamic IP addresses, assigned when needed and different from one time to the next. If you are assigned one IP address that you use all the time, you have a static IP address. Many broadband internet users have a static IP address. There are several other useful tools or services in TCP/IP. Several of these are command line utilities for troubleshooting purposes. Ping is a tool that lets one machine check to see if it can communicate with another. If, for instance, you call your internet service provider because you can't seem to communicate with them or through them, they'll often have you open a command prompt window, type ping, and then an IP address. The resulting data lets them know if, in fact, you can communicate or if something needs fixing. ipconfig reports on your current IP settings, such as address, default gateway, and DNS servers. When using dynamic IP addresses, this program also releases and renews the IP address. NSLookup gives you information on what the DNS server says about a specific host name. Traceroute shows the route a packet takes when going to its destination. If you have trouble reaching a particular website or other network destination, Traceroute can show you where the bottleneck is and whether it's something you can remedy or if it's a wider network or internet issue. Since the purpose of networks is to share resources, including data, once the network is set up, some kind of organization must be put in place so that components and information can be shared among the users. Microsoft designed Windows networks to work in one of three ways, either as a workgroup, a domain, or a home group. These conceptual groups also apply to networks using other operating systems such as Mac OS X and so on. Workgroups are the most basic of these network organizations and are the default for new installations of Windows. This default has a workgroup name of workgroup. Since every computer that's going to be part of the workgroup network has to have the same workgroup name, many people just leave the default as it is. You can change it to something else if you wish. The workgroup network is a peer-to-peer network where all the systems on the network are equal. This works well for small networks, but as a network gets larger, security becomes a greater concern and must be dealt with. This is where usernames and passwords come in. Usernames give you access to your own computer as well as to shared resources on other networked systems. From installation, folders and printers can be shared with others on a network. When you have data you want to share, you can opt to share that folder with others at a couple of different levels of access. Others can read what's in a particular folder, read and save to the files in the folder with read-write access, or be owner of the folder. Giving access to other users can be cumbersome once the number of users on the network gets to be more than just a few others. These types of networks benefit from the domain structure. This allows for more control of data and resources on the network. Domains require a specific server that controls this access. The server must be running a version of Windows Server such as Server 2008, 2008 R2, or 2012. This server becomes the domain controller. User accounts are created here and are called domain accounts. Once you access the domain, you are no longer in a workgroup network. Now you'll log on to the domain controller with your username and password. Incidentally, when you log on at NTC, you are logging on to the NTC domain. A nice feature of domains is that you don't need to log on to every system you're going to use with a different username and password. You are assigned one username and password, and this can be used on any system for access to the domain. This is called single sign-on, and it makes life much easier. A workgroup network has no security, and domains require servers and server operating systems. So a third type of network addresses the gap between these and is called the home group. Home groups allow data, not folders, to be shared. Home groups connect groups of computers using a common password. Home groups must be created, and items to be shared are chosen at this time. The options are pictures, music, videos, documents, and printers. After this, the computer generates a password for the home group. All home group members must use this password to be allowed access to the network. Each workstation that will be part of this home group must elect to join now, enter that password, and choose what they wish to share. Then they are part of the home group network. If a member wishes to share folders with other members, they can do so by right-clicking and choosing the Share option and select the level they wish to share at. You can also connect two PCs together using a direct cable connection. All versions of Windows support this. Initially, this was done with a special parallel or serial cable, but it was a slow transfer. It can be done with USB network cards and a UTP crossover cable, or internal NICs and a UTP crossover cable, or even with FireWire cables. This type of setup is ideal for sharing and moving large amounts of data from one system to another local system. Regardless of the type of network, the protocols used, and so on, the potential for problems on a network increases with the number of systems on and the complexity of the network devices. There are several steps in the troubleshooting process for network issues. First, verify the symptom. This is not always as easy as it seems. The symptom or problem is usually brought to your attention by a user, and most users don't describe problems in the technical language we'd like to hear. They say things like, "The network's not working," and it's up to you to ask questions that will help you determine exactly what isn't working for him or her. So this step includes getting the user to specifically describe what is wrong, and then you need to verify that, in fact, something is wrong. Second, determine when the problem occurred or occurs. Next, what has changed? Most problems don't suddenly appear for no reason, although sometimes they do. Mostly, problems happen because something in the hardware or the software has changed. You'll need to get this information from the user as well. Sometimes users will change things when they shouldn't, and they won't want to admit this, so tact is required here. Fourth, check the environment. This means not only where and in what conditions the computer is used, but also the specifics about a given system itself. What hardware, what operating system, what software, what network it's on, and so on. Fifth, reproduce the problem. If the problem is intermittent, this can be hard to do, but it's essential to do in order to isolate exactly what the problem is. As part of this, you need to separate hardware issues from software issues. This may seem pretty straightforward, but many software problems look like or cause malfunctioning hardware, while some hardware issues appear to be an operating system glitch. Things to try at this point include swapping suspect hardware with known good hardware, uninstalling and reinstalling software or drivers, applying patches or software upgrades, and checking for viruses or other malware. At this point, you may need to do some research. If the fix isn't something simple, you'll need to consult documentation or do an internet search to find the cause of a problem and its solution. Once you do, you are finally ready to fix the problem. But remember, before you turn the system back over to the user, test the system. Make sure it's working properly and that you haven't inadvertently caused another problem. This concludes our discussion of Introduction to Networks.